Hi guys, welcome to JIK 224 E-Kuliah series. I'm Dr. Sumia Sabal and this is the fourth video covering chapter 2, which is chiral versus achiral. So here in this video, I will focus on the difference and similarity and the difference between chiral and achiral. So upon completion of this topic, you should be able to classify molecules as chiral or achiral, draw the mirror images of chiral and achiral, and finally identify and draw any mirror planes of symmetry. So here we have a chiral molecules, which is bromochlorofluoromethane. Okay, it is attached to 4 different groups, which is bromine, chlorine, fluorine, and also hydrogen. So when we place these A molecules in front of a mirror, we will obtain a B molecules. So A and B, they are not aligned together. They are not, it is not identical. They are different molecules and they are non-superimposable. So we can say that bromochlorofluoromethane is actually a chiral molecules. So a chiral molecules is a molecule that is non-superimposable on its mirror image, and therefore A and B is a pair of enantiomer. What about achiral molecules? Here we have bromochloromethane. Okay, we only have 3 different groups, which is bromine, chlorine, and also hydrogen. When we place molecule A in front of a mirror, we will obtain molecule B. Okay, but when we rotate this molecule B, we can see that it's actually identical to molecule A. So we can say that bromochloromethane is achiral. So achiral is when the images are superimposed. What is planes of symmetry? A plane of symmetry is a mirror plane that cuts the molecules in half, so that one half of the molecule is a reflection of the other half. So achiral molecules usually contain a plane of symmetry, but chiral molecules do not have plane of symmetry. So for example here, bromochloromethane here, it has 1 bromine atom, 1 chlorine atom, and also 2 atoms of hydrogen. Okay, let's say here I have these 3D molecules. Okay, what we can do here is that we can place a plane of symmetry, okay, in the middle of between this bromine and chlorine. Okay, so when I place a mirror in front in the middle of these molecules, I have a reflection of these 2 hydrogen atoms that are aligned to each other. Okay, so this is what we call plane of symmetry. We can put a mirror in the middle of the compound or in the middle of the molecules, and we can have a mirror image of each other. Okay, so here we can align the carbon chlorine and carbon bromine bond in each atom, and we will have 2 molecules that are identical to each other. So this is why another reason why bromochloromethane is an achiral. But for this bromochlorofluoromethane, here we have 4 different groups attached to this carbon. Okay, so there's no way we can place a plane of symmetry. Okay, because when we place a plane of symmetry, there is no identical image inside of this molecule. So this is why bromochlorofluoromethane is a chiral. Okay, cis isomer. Here we have cis-1,2-dichlorocyclopentane. Okay, we can place an internal mirror plane of symmetry inside the molecule here. Okay, we can cut through the molecule into half and we will have an identical image of each other. So we can say that actually cis-12-dichlorocyclopentane is the same compound, because when we place this cis-12-dichlorocyclopentane in front of a mirror, we will have an identical compound. So cis-12-dichlorocyclopentane is an achiral because the molecule has an internal plane of symmetry, and both structures can be superimposed. And any molecule that has an internal mirror plane of symmetry is achiral, even if it contains asymmetric carbon atoms or chiral carbon. Even if it has an chiral carbon inside the molecules, if it has an internal plane of symmetry, it is an achiral. Okay. What about trans isomer? So trans 1,2-dichloropentane here, it does not have a plane of symmetry. You can see here that the chlorine atom is actually in opposite direction, so it does not correspond. And when we place the whole molecule in front of a mirror, we can see that its mirror image is different from the structure on the left, so it is non-superimposable. So trans 1,2-dichlorocyclopentane does not have a plane of symmetry, so the images are non-superimposable, and the molecule will have two enantiomer or a pair of enantiomer. So most of cis isomer is achiral, while trans isomer is chiral molecules. Okay. So let's look at example number 1. Draw in a plane of symmetry for each molecule. So we have here 4 different molecules. So now you have all of these molecules are achiral. So now you have to identify where can we place the mirror plane of symmetry. Okay. So for structure number 1, what you have to do is that you have to redraw the structure again, and you have to align these 2 hydrogen atoms. So in the first structure, these 2 hydrogen atoms seem to be in a different place, one pointing towards us and one pointing at the back. Okay, so you have to redraw the structure and align these 2 hydrogen atoms, and then you can place a plane of symmetry. When you place this mirror in the middle of this molecule, you will have a mirror image of the 2 methyl group here. For structure number 2, it seems obvious to you, okay, because you will see here we have an identical group to your left and also to your right. Okay, so you can place a plane of symmetry in the middle here, okay, at the hydrogen atom here, and when you place this plane of symmetry in the middle of this compound or in the middle of this molecule, you will have an identical structure to your left and also to your right. Okay, for molecule number 3, okay, here it may not seem obvious to you. What you can do here is that you can draw the molecule in a 3D structure. Okay, so you take out the hydrogen out, okay, and you can place the plane of symmetry in the middle here. Then you will see, even when we take out these 3 hydrogen out, you will see that when you place this plane of symmetry here, your left and right images is the same. And then for structure number 3, what you can do, you will see that your left and your right images are the same. So you can simply place the plane of symmetry in the middle of the molecule here, and then you will see that these are your left and your right is the mirror images. Okay, what's the difference between chiral and achiral, and how to determine both of these? Okay, so to determine if a compound is a chiral, usually when you have 0 chiral carbon, it is an achiral. Okay, if you have 1 chiral carbon, it is always a chiral molecule. And if you have 2 or more chiral carbon, it can be either chiral or achiral. And then, does the compound have an internal plane of symmetry? If yes, then it is of course an achiral. If no, is the mirror image is superimposable or non-superimposable? If the mirror image is non-superimposable, then it is a chiral. If the mirror image is superimposable, then it is achiral. Let's try to look at this example. For each of the structure, star any chiral carbon atom, draw any internal mirror plane of symmetry and label the structure as chiral or achiral. So we have here 5 structures that you need to identify whether it is a chiral or achiral. So for structure number 1, you see here that this carbon is attached to 4 different groups. So this is the chiral carbon. Okay, then because it have an chiral carbon and also it does not have an internal plane of symmetry, so this compound is a chiral. So for compound number 2, we have here 3 different carbon. So you need to identify which is the chiral carbon. So this carbon will be the chiral carbon because it is attached to 4 different groups. You can see that it has no internal mirror planes of symmetry. So this is also a chiral molecule. For structure number 3 here, the chiral carbon will be this carbon. Okay, because only this carbon is attached to 4 different groups. Okay, when we said that it is attached to 4 different groups, it does not mean that it is attached to 4 different atoms. You have to differentiate here. Okay, for example, in the cyclic molecules, here we have bromine and one is hydrogen, which is not shown. So here we have 1 groups. Why? Because now we have CH2, CH2 also here. Okay, while here, and then we have a double bond here. While here is attached to CH2, CH2, CH. Okay, now we have CH2, CH. So these are 2 different groups. Okay, and also this compound does not have an internal mirror plane of symmetry. So it is also a chiral molecule. For carbon number 4 here, it does not have a chiral carbon and it has an internal mirror image. Okay, so this internal plane of symmetry can be placed in the middle of the molecules. So, and then we will have a mirror image to each other. So this compound or molecules is actually achiral. And then for compound number 5, you see here we have 3 carbons. Okay, and we have 2 chiral center. Okay, this carbon is attached to 4 different groups, which is the methyl group here, hydrogen, hydroxy groups, and also 1 whole bunch of these groups. Okay, and this carbon is attached to hydrogen, chlorine, bromine, and 1 whole bunch of these groups. So it is also a chiral molecules. So as a summary, chiral molecules have non-superimposable mirror image with no mirror planes of symmetry, while achiral molecules have superimposable mirror image with mirror planes of symmetry. So this is the reference, and if you have any question, feel free to contact me at my email address. So thank you for listening.